Okay, so again, you can see that we have a rotating crankshaft that's pushing pistons up and down. So some of the pistons are being pushed up by the crankshaft so that they can create pressure. And some of the pistons are creating pressure. And when they create pressure, they are pushing against the crankshaft, causing it to turn using the standard, piston crankcase, piston rod structure that is used by engines. So you can see that the combustion chamber will generate hot gases. The hot gases will push this piston down. When this piston pushes down, it will push down on this connecting arm to the crankshaft and make the crankshaft turn around. So the crankshaft is being given torque energy by this piston, but these other pistons are being turned, or the crankshaft, the rotation of the crankshaft is pushing these pistons up into their cylinders to compress the gases. And I did, by the way, by mistake, this is a supercharger. So this particular piston does not put energy into the crankshaft exactly for the purpose of making torque available. It's really putting energy into the crankshaft so that the crankshaft can go over here and compress the gases in this compressed air source cylinder. So it, in essence, is a supercharger connected to the crankshaft. The other thing that we will show you is that you do have a crankshaft that's going around and around in circles. And we are not actually extracting torque from the crankshaft external to the engine, unlike other engines. I have a feeling if this was ever made for real, they probably would use this to run perhaps an oil pump and maybe a generator so that the engine would create its own power. But technically, this particular engine is created for the purpose of generating fluid under pressure. And so the torque that is placed on this crankshaft from the burning of the fossil fuel, that torque is immediately converted into a pressure on this water pump. And this water pump has this type of a configuration so that this particular piston of the water pump isolates the water area from the crankcase, because we don't want really getting oil into the water. So the water pump, when this piston goes down, low pressure water comes in, and when this piston is forced back up, high pressure water comes out, and this piston just separates the pumping area for the water from the oil and vapor of oil and gas and heat in the crankcase. This little piston here is not, you'll notice that this little piston is not actually connected to the crankcase. And the reason why it's not is that the moving up and down of these pistons into this crankcase will pressurize the crankcase. And we don't want that crankcase to be pushing air out into the atmosphere and then suctioning air back in from the atmosphere. And so instead what we put in here was a little piston cylinder structure where when the crankcase is pressurized, the crankcase pushes this pushes this piston up into this cylinder, and then when the crankcase loses compression, this piston comes back down. So the crankcase sort of has a auto-balancing crankcase pressure system where hopefully the crankcase will not be required to vent gas to the atmosphere, and the crankcase will not be required to suction in fresh air from the atmosphere.